Hello and welcome. I'm Sharon Spielman with Power in Motion, an Endeavor Business Media brand. Joining me today is Marcus Specks, key market manager at Germany's Have Hydraulic. The company has recently begun to offer technology that integrates telemetry systems and wireless communication in modern tractors. So that's what we'll be talking about today. Let's dig right in. My first question is, how does the telemetry system and wireless communication in modern tractors contribute to increasing efficiency and productivity in agriculture? And how does Have Hydraulics control systems with CAN bus support this trend?
Okay, it's a long question. Let's try to cut it in some pieces.
Okay.
The telemetric system in general is very important in agriculture. I would say it's in a wide field state of the art already. It helps a lot to communicate from one machine to the another machine, or also from the machine to the central office to document data. And especially in agricultural and smart farming, data are very important. And telemetric modules make it more simple to collect the data, to spread the data, and of course to do something with data. Data are nice when you have them, but you must do something with this. I would say agricultural business is extremely advanced there in this area. So they use really the data, for example, to know after you're harvesting, you see the result and you know exactly, okay, in this area it was better, in the other area it was not so good. And this you can use in the next year to set up the right seeds. And this is data you collect, you use them, and you do something with this. And of course, the combination from one machine to the next machine is important. So the information from machine A to getting directly to machine B in the same process when you are on site on the field. We have in our program telemetrics modules, which we can offer. It's hardware, but it's not only hardware, it's also software behind, up to cloud systems we can offer for our customers and help to set them up.
Makes sense. Can you explain a little bit about how that technology works?
From the hardware side, of course, it's a small controller, mainly or mostly a separate small controller, and mobile controllers have special requirements. They must be more robust, depending on temperature, humidity, vibration. So these are very robust units. It's not simple consumer hardware.
Right.
And the protocols or the interfaces are different. It could be in the simplest way via Bluetooth or via VLAN. Then you must be near to the machine. But it could also go up with GSM, so that you have a SIM card and access directly to a satellite. And then you, of course, can bring the data over air to a completely different place.
Okay, so there's a few different ways for them to gather the data and determine what they're going to do with the data.
Right.
Okay,
Right.
I've got
And
you.
then it's you can say, okay, it's either you have only a connection directly to the machine, or you have a cloud-based system where you collect data in a cloud from different machine, and then you have a fleet management where you have a lot of machines and the data are collected in the cloud.
Okay.
So these are different possibilities. You have to discuss with the customer what is his thinking mindset, what is his where did the customer see his opportunities and advantages, and then you can set up the right system.
Right. So, so the advantages of using hydraulic control with electronic intelligence, such as that directional control valve block. So how does it? What are all of the advantages? If you could go over those, that would be great. And are there any disadvantages?
Yeah, the advantages are some different, of course. Always a question how to look on it. I would say the big change in the past, the hydraulics were simple components. I would say stupid but powerful. Real muscles. Yeah, simple, robust, fast, powerful. Now, since a few years, we see more and more integrated electronics on the hydraulic components, mainly on the valves, but also you see it on the pumps more and more and on the cylinders. These are sensors, but also electronics which control the components or take some information via sensors out of the components. So you get much more information about the component. And in case of a valve, for example, you know where's the spool, is it working fine, do you have some wear already or not? It is much more precise. So also the actor behind, it could be a motor or a cylinder, move more precise, and at the end the process is more precise. And this is of course from machine thinking, you or from the end user, he want to have a more precise process. And for this, you need more precise components. And you need more interaction between the components and more information also about the components, about the current state of the components. Temperature is a big important topic, which change in hydraulic a lot of things. And in the past, it was like it is. So in the winter, the machine was behaving like this. In the summer, it was behaving a little bit different.
Sure.
So, and this with some sensors and intelligence, and you can compensate a lot of these pure hydraulic disadvantages.
Got you.
The other thing is, and now we talk about the CAN bus communication, that you simplify the wiring harness. Before, you have one main controller and you have more or less one cable to each of your valves, each of your of the pump or actuator. Now you have one bus system, and when you have a 10-sectional valve, before you need at the end 10 separate cables. Now you have one cable and you communicate via bus, and the valve is doing what it is asked for. So this is one of the next advantages, simplifying the wiring harness, and also cost reduction of the wiring harness, and weight is also a topic, especially for implements.
How are you manufacturing that wire harness?
This is not our part. So the wiring harness on the machine is typically a part of the machine builder.
Gotcha.
And he can save there a lot of money if he only have one cable with 4 small cables inside, or he needs 10. Of course, we have, especially with the PSL CAN, this is a sectional design. So you have 10 sections, 10 onboard electronics, and normally you have also there the need of cable to cable to cable. And we have a very flat and clean design there with a covered flat cable system, which is unique in the market. And this is very robust, very compact. And also
Right.
here
And
we
with
have
all the vibrations and the temperature
yeah,
changes.
right. Yeah. So this is
Okay.
also one topic. One important point is we really should mention this in the right way. The communication between the tractor and the implement is not done via CAN bus. So this communication, there's a so-called ESO bus. The ESO bus is also a bus system, ESO, ESO bus. And this is a standard which is defined from the complete agricultural group. And the intention is, of course, that each tractor can communicate with each implement independent from the manufacturer. So communication between tractor and implement is ESO bus, but communication on the tractor or on the implement is CAN. And when we look to the implement, for example, a sprayer machine with a lot of function, and big machines now with high precision movements, there it helps a lot that you have one main controller, one CAN valve, only one cable in between, perhaps some sensors, also these sensors connected via CAN bus. And this simplifies the machine layout a lot, helps you also to make service more easy. That's, I would say, also one advantage. Yeah, and you ask for the disadvantages. The disadvantages in the past, and I would really say in the past, was that electronics were not so reliable and made not so a good job in mobile machines. But this problem, I would say, is solved since 10 years. Since then, I would say we have no problems with electronics, with onboard electronics, with controllers in mobile world, and also the service topic is solved nowadays. So the typical problems where the people were a little bit careful and say, oh no, I don't rely on CAN bus. This is gone. And I would say CAN communication is now state of the art. And what we at least see is, I would say more than a half of the new projects we have, we talk with the customer directly about CAN bus systems.
Yeah, it's come leaps and bounds. I think the technology has really come a very long way, and
Yeah.
not in a very long time. So you know, it it's really jumped forward. And I think electronics is always scary, especially when you're thinking of, you know, really harsh environments like that in agriculture. So
Yeah.
it's nice that we've come so far in the technology and they're able to benefit from it. And speaking of that, can you think of any end users? Maybe you don't have to list any names or anything, but if you can think of a type of end user that has maybe some stats to share on the efficiency or productivity that they may have realized by implementing this?
Yeah, yes, of course. Especially when we talk about, of course, bigger and more complex machines, like bigger field sprayers, like liquid manure is a, I think, English word for it. Fertilizers. Also very complex machine, which has a very precise process. That's very important. Also seeding machines, where you have where each seed corn is placed separate. So, and when you look to the machines, extremely big machines with a few meters of wide. And there you have a lot of hydraulic functions, and they will be also in the future hydraulically. Then you need a lot of valves, then you need a lot of cables, and then you're not really knowing what the valves are doing because you have no sensors. And they see a lot of benefits now to switching to the CAN bus system, where the valves have onboard electronic, where you have a diagnostic of the valve, and as I said, more simple harness, wiring harness. And these are the machine types where we have a lot of discussion and where you see the first changes in the direction of CAN bus technology on the machine. On the other side, there are a lot of more mechanical, pure mechanical earth machines, earth changing, earth moving machineries or processes. Here we have no need of high sophisticated valves and onboard electronics and CAN bus systems.